Welcome again, everyone, to Science and Engineering World, where we have fun doing mathematics, more mathematics, much more mathematics. In this presentation, I will be demonstrating practical application of trigonometric ratio, climbing up a ladder like this, and finding the length of the ladder and other various dimensions. I've designed this question for the demonstration. Before we go to do it together, I want you to give it a try yourself and see if you can get just the length of the ladder. But just for the length, I got a solution which is 3.897 meter. If you get this, I'll give you a thumb up before you give me one. Right, and put your solution in the comment below, and then you get my thumb up. Let's go, and then we'll come back to look at it together. The statement of the problem says that a 1.5 meter tall internal decorator placed a ladder on a vertical wall at angle 60 degrees to the floor. When the decorator climbed 2/3 of the length of the ladder, she stood vertically on it and her head just touched the roof. She observed the tip of the ladder at 30 degrees angle of depression. The statement just gave us three values. Number one, the height of the decorator, which is this. When she has gone 2/3 of the ladder up, so the remaining part of the ladder is 1/3. And then we have angle 60, which is the ladder against the floor. When she looked down from where her eyes are in the roof, she was able to see the tip of the ladder at an angle of depression 30 degrees. Now we're going to model this problem by just giving the ladder length L, because we don't know the length of the ladder. As we go on, we try to find all the other dimensions in terms of L. The questions now are, number one, what is the length of the ladder, which I'm making to be L? Number two, how far is the foot of the ladder to the wall, which we are giving the value of F? And number three, what is the vertical distance of the tip of the ladder to the floor, which is letter Z. Number four is that how much space is left from the tip of the ladder to the roof for the decorator to work on, which is X. And the last question here is that how far is the roof to the floor, which is now H. The first one is we want to find F, which is the distance on the floor, and the Z, which is the height of the tip of the ladder to the floor. Now to find F, we use cos 60, cos of 60 degrees will be equal to F over L, that's adjacent over hypotenuse, F over L. So from here, we have 60 and 30, and from some videos that I've done before, which I'm putting the links below, you will see that cos 60 is half, 1 over 2. That's equals to F over L. And so we can say that F is equal to half of L. To find z, which is the height from the tip of the ladder to the floor, we use sine 60. So sine 60 degrees equals to opposite over hypotenuse, which is z over L. So we can say from here, from the clips I've mentioned that the link is below, you can see that sine 60 is root of 3 over 2, which is equal to z over L. So we can say that z or z in some pronunciation is equal to root of 3 over 2 L. So we have these two defined, that is f is that, half of L, and the height from the tip of the ladder to the floor is root of 3 over 2 L. We need to find p, y, and x, and we are going to use the two small right angle triangles at the top of the ladder to the roof. So with these two small right angle triangle, we can find p because we need it for the top one, and then we can find y and x. So let's first of all find p. Cos 60 degrees will be equal to p over p is adjacent and hypotenuse is 1 over 3 L. So we also know from the link I've mentioned that cos 60 is 1 over 2, as 1 over 2 equals to p over 1 over 3 L. So p can now be taken to be half multiplied by 1 over 3 L. So in this case, we can say 1 times L will give us L, and then 2 times 6 will give us 2 times 3 will give us 6. So we can now say from here that P is equal to 1 over 6 L. P equals to 1 over 6 L. Okay. Now, what about Y? We can find Y by looking at the sine 60. So sine 60, sine of 60 degrees will give us opposite over hypotenuse, which is y, over hypotenuse, which is 1 over 3 L. And then we have demonstrated that sine 60 is root of 3. Sine 60 is root of 3 over 2, which is also equal to now y over 1 over 3 L. So we can put here that y equals to root of 3 over 2 times 1 over 3 L. And that gives us y to be equal to 1 times root of 3, that's root of 3, and 2 times 3, that gives us 6 L. So y is root of 3 over 6 L. Okay, so now we can now find x by using the order at the top right angle triangle, and we can see here we have angle 30 degrees, we have p as the base and then x as the vertical. So the right trick to use is tan. So we can say that tan of 30 degrees will be equal to, tan is opposite over adjacent, so tan, that will be x over p. Good, x over p. But if you look at it, let's find this out again. We said that tan 30 from the clip we have seen before is going to give us root of 3 over 3. That is giving us x over p. So x equals to root of 3 over 3 times p. But we have p already here in terms of L, so we can now say that x equals to root of 3 over 3 times 1 over 6 L. Good. So x will now give us root of 3 times 1 is root of 3, and 3 times 6 is 18. That's 1 over 18 L. So that's our that's our x, which is root of 3 over 18 L. So we've been able to find all those dimensions in terms of L. So here, I put all the values that we have obtained together. We have F, we have Z, we have P, we have Y, and we have X. So these we've modeled all those dimensions in terms of L. Now let's look at the questions that are given, 5 of them. So let's start looking at them one by one. We want to find the length of the ladder L, and in this problem we have only been given the height of the decorator, which is 1.5, and 1.5 can also be written as 3 over 2. Okay, so we can now say that the length of the height of the decorator is a combination of x and y, which means that x plus y equals to the decorator, which is 3 over 2. Now x we have seen to be root of 3 over 18 L, and plus y we have seen to be root of 3 over 6L, and this will give us 3 over 2. So we have a simple equation here, just one linear equation with value of L unknown, so we should be able to find this easily. And a quick approach is to use, you can first of all multiply all the equation by 18, which is the highest denominator here, and that will remove all the denominators. So we can now say that 18 times root of 3 over 18 L plus 18 again times root of 3 over 6 L will be equal to 3 over 2 times 18. So we can see in this case that 18 will go in 18, so we have root of 3 L plus 6 will go in 18 3 times, so we can now see 3 root of 3 L to be equal to 2 will go in 18, 9, and 9 times 3, so this will be 9. 9 times 3 is 27. So we have this simple straight line linear. We have this linear equation. The first term here is 1 root of 3L, and the second one is root of 3. So we can bring root of 3 out, and we add the coefficients together. So we are going to have, in this left hand side, we are going to have 4 root of 3 L to be equal to 27. All right, good. And we can then write that L equals to, now, root of 27 over this coefficient of L. So we're going to have 27 over 4 root of 3. So that will be our L. And then we can, we need to rationalize here. We've talked about rationalization again. If you look at that video, which I put the link below, so we can now rationalize this to give us 27 or root of 3 times, because root of 3 is a rational number, so we use it to multiply. So we multiply this by 1 by saying root of 3 over root of 3. So that's how to rationalize that. And so we can get that our L is equal to 27 root of 3, 27 root of 3 all over root of 3 times root of 3 is 3, and that gives us 4 times 3. Again, we can see that 3 will go in 27 9 times. So we're going to have here 9 root of 3 equals to over 4. So our L is equal to 9 root of 3 divided by 4. So we have our value for the length of the ladder now, which if we put the root of 3 as a value, we have seen root of 3 is 1.732. We'll be able to find the length of the ladder accurately. So we can find length of L because we know that root of 3 is, that is 9 times root of 3 is 1.732 divided by 4. And by the time you multiply 9 by 1.732 and divide by 4, we are going to have 3.897 meters. So that will be the length of the ladder, which is 3.897 meters. Again, we want to find the foot of the ladder to the wall. And we have seen from the formula we obtained that F equals to half of L. So we can put here 3.897 divided by 2, and that will give us 1 point remaining 118, that is 9. Then 9, the others 4, and then 7. So that gives us 1.947 meters. That's the foot of the ladder to the wall. Again, we have here the tip of the ladder to the floor. We've seen is z, which is equal to root of 3 over 2. So times L, we can now say here that z equals to root 3 is 1.732 over 2 times L, which is the length of the ladder, which is 3.897. And this gives us, by the time you put all of this in your calculator, you will get 3.375 meters. So 3.375 meters. That's the distance of the tip of the ladder to the floor. Okay. Now, for the space above, which is x, we see that x equals to space for the decorator to use. We have seen is root of 3 over 18 times L. Root of 3 is 1.732 over 18 times the length is 3.897. That's the length of the ladder. And by the time you do some calculation there, we're going to get that 0.375 is the space that is left for the decorator to use. So that is this space the decorator is going to use to paint or to do whatever. Now, the last one is getting the roof to the floor, which is h. And we can see that this is just x, that's the top there, plus z, x plus z. From the values we obtain above, we can see this is equal to x is 0.375 plus where's z? Z is 3.375, 3.375, and that gives us, by adding all of that together, it gives us 3.75. Because we have been working in 3 decimal places, so I can put my 0 there in meters. So that is the roof to the floor. We have done the calculations for all the dimensions that were required. Now let's throw more light to the design. In this pictorial view, we see that we have the ladder against the wall, and then the decorator at that point where her head is touching the roof. Now we see more here that the ladder is going to be shifting from one end to the other in order for her to be able to do her work on this space where she wants to do the decoration. I hope we have been able to understand this evaluation of a trigonometric ratio, even without using much of calculator anyway. And we were able to model this by putting all dimensions in form of L, because L can vary. If we vary L, then we will be able to obtain the other values very easily. And then when I look at my values, I try to evaluate whether I'm in the right direction or not. I can see this triangle the ladder has formed, that it has the ladder itself is an hypotenuse, and the wall and the floor are the other two sides of the right angle triangle. And I can see the ladder, which is 3.897, which is supposed to be, and it is from this evaluation, that is the longest side of the right angle triangle, while the wall is 3.375 and the floor is almost 1 point. So I think that we are in the right direction. If you find this video very useful, like I did at the beginning, give it a thumb up, and then share it with others so that they can enjoy the same thing you have seen. Comments. Like I always say, there are so many other methods we can use to arrive at the same values in mathematics or even in every other thing in life. And then subscribe for us to be able to get more views, and then at the same time you'll be able to get the more video clips as I post them on this channel. And like I always say again, mathematics is fun, so keep having fun. And lastly, until we meet next time, keep studying.